Hello and welcome to this video on applying Pythagoras' theorem. Now, applying Pythagoras' theorem is usually done in terms of word problems, or in at least our context, it is done using word problems. So we're going to go through the steps involved in word problems, and then we're going to work through a word problem and see where we get to. Now, the very first thing that you want to do for a word problem, it doesn't matter what kind of a word problem it is. It can be the Pythagoras word problem, it could be measurement, algebra, finance, anything at all. If it's a word problem, some of these things are going to apply. And the very first step is something that will apply. And the very first step is to read the question. Okay, we're going to read the question and underline or highlight key terms. Now, the very important thing with the read the question bit is that we want to do this very carefully, because we want to make sure that we've read the question, we understand exactly what it is that it's asking of us. So that's why we need to read it carefully. So go over it really slowly, go over it a couple of times, underline those key terms, okay, or highlight them, whatever you need, so that you know what you need to pull out from those words. The next step, it may be required, it may not be, but if you don't have one of these, you should probably put one in, and that is draw a diagram . We're going to draw a diagram and label the features or the important information. So this is all the stuff that we have gleaned from reading the question properly. Okay, so this is all from the question. Okay. So far we have read the question incredibly carefully to make sure that we know exactly what it is that it's asking of us. We've underlined key terms, we've drawn a diagram, and we've used that key information to label the diagram. And I have misspelled label, so let's go back and fix that. Label the diagrams. Third step is to, in this case, this third step is specifically for Pythagoras' theorem. We need to decide or determine if it's a hypotenuse question or if it's a short side question. Because if you refer back to the previous video, there are essentially two separate formulas. There's one for the hypotenuse and one for a short side. So you need to know which one you're going to be using, because if you don't use the correct one, it may not come out the way that you want it to come out. The fourth step, pretty easy one, this one. Actually use Pythagoras' theorem. To calculate the solution. Now, the other thing with this is you want to make sure that you are recording the working out. Really important that we record all that working out. That way, if our solution isn't reasonable or it's incorrect, we can go back through and see where it is that we've actually made the error. So lots and lots of you out there are probably thinking, why do I have to keep writing out everything I'm doing? It's just so that we could find those errors and fix them without having to worry too much. Like, it just makes it easier to be able to help everybody figure out what's actually going on. Okay, and it actually shows that thinking process on the paper. Our fifth step is exactly what I was just talking about. So that is check the solution for reasonableness. Reasonableness, if I spell that correctly. Reasonability is probably a better way to say it. For reasonability and correct units, like the units are correct. Okay, so we want to make sure that those units are correct, usually coming straight from the question itself. And we're checking that solution for reasonability. So essentially, if we have a question where we're finding the hypotenuse and our solution gives us an answer that is less than either of the other two sides, obviously we've made an error in there somewhere and we need to find that error and fix it. If it is giving you an answer that is way, way, way too big, for example, you've got a long side of 5 and a short side of 3, your other short side should be 4, not 54. Okay, so we need to make sure that we're making reasonability judgments around our solutions as well. And because it is a word problem, we are going to put our answer in words. So we are going to explain the answer in words, or the solution in words. Okay, just to make sure that we've answered the question. So we want to answer that question completely. Okay, so these are those steps that we're looking for actually completing a Pythagoras Theorem problem. Okay, let's actually do a problem now. Alrighty, so here we have our problem. We have a helicopter is at a height of 200 meters above the ground. Its horizontal distance is 320 meters from the landing pad, and we want to know the direct distance of the helicopter from the landing pad, so the actual straight line that helicopter is going to take to get to that landing pad. So let's have a look first. We need our highlighter. So we're going to go through, we've read our question, we've got a helicopter. It is 200 meters high and 320 meters away from the landing pad in a horizontal distance. We want to find that angular distance, essentially the direct distance of that helicopter from the landing pad. So we've got our height of 200 meters, we've got a distance of 320 meters. We want to find the distance of the helicopter, and we want to do it correct to 2 decimal places. Now I've highlighted that 2 decimal places bit that is going to come in important fairly soon. Now the next thing I'm going to do is I am going to draw a diagram. Okay, so I'm just going to start. I'm going to pop some space up here. I need my helicopter, so I'm just going to draw a really badly drawn helicopter. There's my badly drawn helicopter, as you can see. And we know it is 200 meters above the ground. I've got a helipad over here. Let's put my helipad there. Alright, poorly drawn helipad. And it is 300 meters that way. and we give it our nice little right angle just to remind us. Now we're actually looking for this distance that I've drawn here in purple. Okay, so this distance here is the hypotenuse. So we're going to use our hypotenuse formula. Okay, so pop in the 320 meters here. Alright, so we can make this A, B, and H. Alright, so let's go back up to where the writing is and let's get started. So let's start with our formula. Our formula is H squared equals A squared plus a B squared. H squared is the one that we're looking for, and we've said A is 200 and B is 320. So that's what we're going to pop in. Okie dokie. Now, again, back to the previous video, easiest way to do that is to do your square rooting now, because our calculators are amazing tools. If you don't have a proper scientific calculator, get one. They are legitimately amazing. Okay, so we square root H squared and we get H. Then I use my square root symbol and I pop in 200 squared plus 320 squared, and we can type that straight into our calculator to give us our approximate answer of 377.36 meters. So again, this is all just two decimal places. Okay, now we get to finish off with a bit of a worded sentence, and it's pretty simple. Just the helicopter is approximately 377.36 meters from the helipad. And that's it. That's how you do it. So all we've done is we've taken our word problem, we've read it carefully to discover all the bits and pieces that we are working with, and put it together into the equation, get our answer out, chuck it in a word sentence. Easy as pie. Hopefully that has helped. Good luck with your questions, and thanks for watching.